Are we ready? Okay, go. There we are. Hello? Can you hear me okay? Excellent. Hi, everyone. My workshop Norwegians did a much better job of greeting me. Hi? Okay, excellent. You're here then. You're awake. Good. Thanks for coming, everyone. My name is Brock Allen. I'm a consultant. I call myself an identity architect these days, kind of a nifty, unique title. I basically help companies with their identity architecture and their application security. And I focus on things like, identity management, storing passwords, doing MFA, getting users logged into systems, very often doing things like single sign-on with OpenID Connect, having apps invoke APIs, securely with OAuth 2, and a lot of that also then revolves around authorization, right? Once we know who the user is, what can they do in the apps? So when I'm not doing work for customers in those topics, I spend a lot of my time doing some open source work on a couple of projects called Identity Server and Identity Model. Identity Server is a framework for helping you build OpenID Connect and OAuth 2 servers to help achieve those identity architectures of single sign-on. And Identity Model is like a little helper library that you can use from an app to connect to those servers. I also do some commercial product work for authorization in something called Policy Server. So this session is about how from JavaScript applications running in the browser, we can authenticate calls securely back to our web APIs. I'm mainly talking, about client-side browser-based applications. I'm not talking about, when I'm saying JavaScript, not talking about server-side Node.js type of apps. So these are purely client-side browser-based JavaScript applications. So what we're going to do is look at a couple different approaches for authenticating calls when you're making these AJAX calls back to the server. And then we'll talk about a couple of threats you need to be aware of when you're building your JavaScript SPA applications. The majority of this session is about mitigating against one of those threats, which is a cross-site request forgery attack. And we're going to see a couple different or a few different styles for protecting those APIs, depending on your app requirements and what architecture you kind of need based on your identity architecture for your applications. So when we have JavaScript running in browsers, we have a couple different styles for how we make calls back to the server and authenticate those calls. So one kind of half of those apps that I think of the more traditional or the older applications that you might be building where you have some server-side code running that maybe is rendering HTML, and that server-side code needs to know who the user is. So chances are, because you have a server-side application, you're using a cookie of some sort to do authentication, right? Very, very traditional type of thing. And then, one day you discovered something like jQuery, and you're like, oh, wow, I can actually put code in the browser, right, and do something more dynamic, and I can make AJAX calls back to my server. And it just sort of worked, and authentication just worked in those AJAX calls, basically because you were sending a cookie along, okay? And that's kind of what we like about cookies for authentication, is because the browser is automatically or implicitly sending them to the server. So totally works for AJAX calls, and that's why we like it. It's nice and easy, okay? So that's one style. The other style is more the newer style of JavaScript or SPA applitions that we're developing. These are more like pure Angular or React, where you're building the application so that the entire UI is executing and rendering in the browser, and you really have nothing on the server other than an API somewhere, and that might not even be running with your app. It may be on a totally different domain somewhere. And so that's almost the style where maybe you could even deploy it from a CDN. Okay, you have nothing really executing on the server. So how you authenticate that style of app? Well, you actually have a couple more choices there. You could still try to do cookies if you had something server-side, but another architecture is to use token-based authentication, and we're going to talk about sort of the pros and cons of those. So the couple main threats that you need to be aware of when you're building JavaScript applications running in the browser, right? The first and foremost is cross-site scripting attacks, okay? So that's one of the still most common types of attacks on the web, where an attacker can somehow pass parameters into your application interprets them as some sort of input, but you're interpreting it and executing it accidentally in your application, right? String concatenation, and it's the same idea with server-side things like SQL injection. So a couple of the mitigations that you probably are already using, but if you're not, you need to be aware of them, is obviously HTTP-only cookies is one thing to use there, right? The idea there is that when you issue your cookie, from your server-side application, you don't want the cross-site scripting attack in your page or in your user's app to somehow exfiltrate the cookie. Because then the attacker could just send the cookie out to their, to their server and then replay the cookie into your app, and of course they're in. That's a really easy mitigation because you can just mark it on the cookie and it just happens automatically because the browser is enforcing it. So that's a nice mitigation. It's not really necessarily the best mitigation because, of course, if the attacker's running JavaScript in the page, well, they can just submit AJAX calls back to the server as if it's the user. So, protecting against exfiltration of the cookie is only one sort of a defense. So yeah, we still need to protect against that code running in the page because then it could do whatever the user is doing. So content security policy, right, is a very important feature for doing that. How many of you use this today? Actually, that's pretty decent. I'd say a quarter of you. That's better than maybe a year ago. So if you're building a SPA JavaScript application, just hands down, you should absolutely be using content security policy. And the talk is not about content security policy, but I will briefly show you or mention what it's about. So the idea is, I'm just using GitHub as an example here. When your HTML page renders from the server and renders into the browser, you can emit a HTTP header from your server-side application called content security policy. And this is basically a feature of browsers, modern browsers, and you're basically telling the browser that you don't want any JavaScript to run on the page, okay? And that's actually going to solve our cross-site scripting problem, right? Absolutely. No JavaScript, no attack, okay? Ah, right, you're building a SPA, I forgot. Okay, so we actually want to protect or enable other parts of the application to run, which is your code, the legitimate code, okay? So basically the way this works, you add it in the page, it disables pretty much all JavaScript, and then the idea is you come down here and with some additional directives, you are telling the browser which scripts you do trust or you do want to allow to run. And there are a variety of ways of doing this. One way is you can indicate the host name or the domain name that your scripts are coming from that you trust. If that's a CDN, I don't know if that's going to really help you because a bad guy can also put their script up on a CDN. But if it's your own domain, you can do that. There's another technique where you can even do the hash of the block of JavaScript that you want to allow to run. Okay, that's actually really locking it down. Okay? So again, this talk is not really about that, but if you don't know about it, you really should be using it. And use it and introduce it as soon as possible into your application architecture as possible, because the more you're basically deliberately restricting things that can run on the page. And so if you have a whole bunch of JavaScript that you're building that goes off and does inline scripting and things like that, you're really, kind of painting yourself into a corner. You're making it harder for you to be able to use this, okay? So again, you should be using this for any kind of JavaScript you're running in the browser. All right, this, by the way, has other features as well. It's not just what JavaScript can run, it's like what CSS can run, what domains can you connect back to for AJAX calls and WebSockets, what web fonts will you allow to run, what origins, iframes are allowed to be running, which origins you can post to for form post from a form element, all kinds of things like that. So you really should look into this and be using it in your apps. It's going to be your best defense against cross-site scripting because it's really the browser who is sandboxing your app and helping you out, okay? So the other main attack, which is really what the rest of this talk is about, is something called cross-site request forgery, and we have a few different mitigations against that, like I said, depending on your application architecture. So real quick, what is a cross-site request forgery attack? The idea is that you have logged into an application, and again, this is a scenario where we're using cookies to authenticate our AJAX calls. So the server-side application, your user's going to go log into that, username, password, whatever, you're going to get back a cookie into your browser. Great. Your app can make requests, that cookie gets sent. Your app can make AJAX calls, the cookie is sent. Great. Now, the end user is somehow fooled into opening up another tab. They go to some malicious website, and that malicious website also makes requests over to your application. Okay, something like a GET request, maybe they put an image tag over to some endpoint in your application, or they have a form element, right, to some action in your application, and then they write a line of JavaScript to auto-submit it. Okay? This is something you need to protect against because when the attacker runs that code in the user's browser, the cookie will be sent. Okay? So even though the page submitting to your application is from an entirely different domain, because your app previously issued the cookie, the browser is going to automatically send it. That's just how cookies have worked forever. Okay? So again, the attack here is the attacker is taking advantage of the fact that your browser implicitly sends the cookie. Okay? This, by the way, is also a valid attack if you're using other types of credentials that the browser is implicitly sending. If you're doing integrated Windows authentication, if you're doing HTTP basic authentication where the browser prompts, right? Or if you're doing even like client certificates, like an X509 certificate, or a smart card, and the browser prompts you for it, and you send it in. All of those credentials, you've asked the browser to kind of manage and therefore implicitly send on every request, okay? So all those scenarios you need to protect against. So how do we do that? One approach is something with an anti-forgery token. An anti-forgery token is basically, think of it as like a credential that proves that your app is the one making request. Your HTML is making the request back to your server-side application. And so the trick about this is that your application or your HTML has to explicitly send the value. Okay, that's kind of the difference, right? Instead of an implicit, it's an explicit credential. And so this is pretty easy to do if you're doing like ASP.NET or even MVC, because what happens is when your code is rendered into the page, right? I'm sure you've all seen this if you've done any kind of Razor programming, where in the form tag, you put HTML.anti-forgery token, okay? And what that does is it creates a random value, that's the anti-forgery token, it issues it in a cookie, and it renders the value, that random value, into this form element as a hidden field. So then whenever your page is posted back with a normal button click, like a normal submit, right, because that's just a hidden input that's in your form, it's automatically sent along. And on the server, you have that validate anti-forgery token attribute, and that code on the server reads the cookie, reads the hidden form value, and compares the two. And what that's doing is proving that the form that submitted the page came from your server. It's your code, okay? An attacker on their website, they could make the call, the anti-forgery cookie would be sent, but they have no way to know the value in that cookie. Because the cookie came from your domain, so they can't read it, and it's such a high entropy value that they would never guess the right value to put in here. So then when they submit, it just won't match, and your server can reject the call, okay? This technique has been around for a very, very long time, right? The trick is, or at least when it comes to JavaScript applications, did you remember to send it when you made your AJAX calls? Right? Did you remember to send along the anti-forgery value that was from the hidden field when you do $AJAX, right, using jQuery or something like that? Very often, people forget when they're just adding a little bit of JavaScript to the page to make that call. They forget to actually send along that anti-forgery value. So for those particular endpoints, you might have the possibility of a cross-site request forgery attack. Okay? So that's a concern. So anyway, that's one way to sort it out. So you could use cookies, and as long as every request you're sending an anti-forgery value, you've protected those calls. Okay? That's one style. Now, turns out there's actually a newer feature in the last 6 or 9 months that browsers are really starting to implement. And it's something called same-site cookies. Okay? What a same-site cookie is basically when you issue the authentication cookie, the cookie you're using to know who the user is in your application, you can add this new attribute called same-site. And that's a flag to the browser. So again, we're going to fall back and have the browser help protect our application. It tells the browser that this cookie should only ever be sent back to the server if the page making the request is from the same domain. Okay? So that totally solves the problem, because now when you go to the malicious domain, the other tab in the browser, it's from a different domain, it makes the cross-domain call, and the browser basically says, oh, the cookie's not supposed to go cross-domain, so therefore the browser will prevent it, okay? I don't know why they didn't do this 10 years ago, honestly. This really would have helped us a long time ago in terms of helping us with this cross-site request forgery vulnerability, and basically this is a substitute for using anti-forgery. Okay? The only gotcha about this is that it is, as I said, sort of a newer feature. So depending on the browsers that you have to support, you may not have, not have this available to you. So if you have to support like an older Android or iOS version running older versions of those browsers, or Safari, it looks like only the current version has it, or even the point release. So I don't know if you can quite totally rely upon this feature, but I think in the next 6 to 12 months, you'll be able to. Okay? All right. So that is another approach for addressing the cross-site request forgery issue, is to use same-site cookies. And again, you're letting the browser do the protection for us. Okay. Now, there's got to be a downside with same-site cookies, which is, there's some architectural constraints there. One is that your API has to have something on the server side that issues the cookie, okay? Some APIs aren't built that way, right? They're built to just sort of be standalone. You call them, and they don't think about the fact that there's a browser there. I guess that also means that you have to have a browser being the client application. So if that API wanted to be invoked by some server-to-server call or some mobile app that you're building, those don't do cookies, so that's also a problem. What else? Oh, of course, it has to be in the same domain, right? That's what same-site cookies mean, right? if you have to call these cross-domain, that's not going to work either. And what else? Well, I guess that the same-site cookies are still new. So, there might be some architectural reasons why you can't use same-site cookies, okay? So what are we going to do instead? Well, there's a different architecture that uses something called a token-based authentication design, if you will. A token, again, is just another type of credential. The main difference is that this is something that needs to be sent explicitly. So this token is usually a JSON web token or a JOT, if you've ever heard of those. I'm sure you have. This is sent as the authorization header explicitly every time you make a call, like an AJAX call. Okay? And so again, this basically gives us a level of indirection from the browser, right? So it's not a cookie that's really a browser feature. It's just an independent thing that can be sent on every call, and it can be validated. These are self-contained. They have a digital signature, so they can't be tampered with. They can be obtained by any type of app, so it just doesn't have to be just a browser-based application. We can call cross-domain. There are lots of nice benefits for this architecture. It is more complex, though. Okay, so this is a trade-off for those benefits. So how do we get these tokens? Well, guess what? There's some protocols for that, okay? So there are a couple protocols, OpenID Connect and OAuth 2. OpenID Connect is built on top of OAuth 2, so you typically are using them at the same time. And basically the design of these protocols is you actually get 2 tokens. One token is meant to be used to call to the API, and that's something called an access token. And then there's another token called an identity token that is meant to be consumed by the front end of the application, and that's for the authentication piece of things. So your JavaScript app might like to say, welcome back, Brock, and then the JavaScript SPA wants to call an API. Okay, so the ID token is going to contain my name for the front end, and the access token will be used to call to the back end. Okay, so these are the protocols that are the standards for building a SPA to obtain these type of tokens. Basically, the high-level architecture is you're in your SPA. You are going to typically redirect the user to some place that issues these tokens. And so we call that thing the token server that implements these protocols. The user will do their authentication there, username and password, log in with Google, whatever. And then it will issue tokens back to the app. And then the app will, of course, use the tokens to call the backend API. So really, that backend call is just that access token, and that identity token is meant to stay in the SPA to let the front end know who that user is. Okay, so the details of this sort of redirection to the token server and the receiving the results back into your client app, the OAuth and the OpenID Connect specification describes these as flows or protocol flows. And there are a few different flows in the protocol for different application scenarios. There's some flows for where you have a server-to-server call and there's no user, and there are other flows where you have a front end and the user is interacting with the app, and we need to do this redirect in the browser. So there has actually been some changes in the spec recommendations in the last 6 or 9 months. A while ago, or when the OAuth specs originally came out, the flow that they recommended for SPAs was something called implicit flow. And it turns out that the movement in the spec committee is to deprecate the implicit flow. Mainly because when the implicit flow was first being developed, it was way back in 2012, and to use the code flow, which is actually the primary recommended one, to use the code flow, there are certain API calls that do have to happen cross-domain. And so at the time, to do cross-domain calls, for that to work, the browser had to support CORS. Okay? Well, at that time, CORS really wasn't widely deployed, so they couldn't take a dependency on it. So that's why they had to come up with this implicit flow, which was like a shortcut version, an optimized version of these protocol flows to accommodate the fact that these browser-based apps were a little bit hobbled because of the nature of cross-domain calls. Since then, though, of course, more and more browsers are implementing CORS, and so now the spec committee said, hey, yeah, we've always wanted to do something better, more modern, and more, and also a consistent flow. So they have now moved back to using the authorization code flow as the primary recommended approach for these SPAs, because again, now we can do CORS and do these cross-domain calls when you need to invoke back to the token server. Okay? Now, it turns out their authorization code flow itself has some problems. There's a substitution attack called the code substitution attack. And so since then, the working groups have also added another RFC to kind of fix the hole, or patch it, if you will. So what they've introduced is another specification called PKCE. PKCE is the acronym there. It stands for Proof Key for Code Exchange. So the idea is that you need to be using CodeFlow with this PKCE spec to have a nice secure approach for your browser-based application. So I'm going to talk through the details of that, and hopefully it'll make more sense. So what this means is that your SPA needs to go and talk to this token server through these protocols. For the token server, for your app to talk to the token server has to have certain endpoints. These endpoints are defined by the specification. So one of these endpoints is called the discovery document. It has metadata about your token server. There is an endpoint called the authorization endpoint. This is the interactive endpoint that you redirect the user to. And then there's a programmatic endpoint called the token endpoint, and that's the one that we will now be invoking to get our tokens. So here's what the discovery document might look like. It's basically a URL under the base address of your token server. I don't know if you guys can see here. If this is the base address of your token server, then the discovery document is always under this well-known path. It serves up JSON so that your client application can then know the other metadata it needs about the token server, namely, what are the two URLs for the other endpoints that I need to interact with. Just makes it easier for your app to configure against the token server. So the protocol works like this. The users in the SPA, they basically, the SPA says, hey, I need you to go log in. Right? So it ends up redirecting the user to the authorized endpoint. Okay? Again, to know the authorized endpoint, it probably first made an AJAX call that loads the discovery document. Then we know the URL. We redirect the user to that authorized endpoint. There are several parameters that are passed to the authorized endpoint to let the token server know what app is making the request. That's the client ID, and where to send the results, which is the redirect URI. And the one thing about which protocol flow here, this parameter called response type, that is actually what is controlling the fact that we are now using code flow instead of the prior implicit flow, if you are familiar with that. So there are some other parameters here. The other main one here is the fact that I want some access to some identity information. So this OpenID and profile, these are called scopes, which allow the app to get user information. This is what is going to affect the claims that come back in this identity token, so the front end can say, welcome back, Brock, your first name, last name, whatever other information. And then, of course, actually, email's in there as well. I missed that one. And then the other thing that you want access to are certain APIs. So there are other scopes here that represent the APIs that the SPA wants to invoke. And so API 1 and API 2, those are going to affect the access token and allow you to call those two different APIs. Okay? So what happens then is the request goes to the token server. The user then will log into the token server with whatever type of account the user will have there. So it could be password, could be social logins, could be a business login, federation with Azure Active Directory, whatever. And then the token server says, great, you're now logged in, we know who you are, and you will get a cookie at the token server that represents your single sign-on session. And then the token server redirects back to the application with a parameter called a code. This is what's called the authorization code. This is not the access token, this is not the identity token, but it is the thing that will get you to the tokens, okay? Now, in the implicit flow, the prior flow that was deprecated, what would happen is the tokens would be sent directly in this URL. Okay, right there in the URL back to the SPA. The SPA could then just read them and start using them. Okay, that was the main complaint about the prior flow, is the fact that it's in the URL and it's in your history, right, of your browser. And maybe your browser is pulling in, images from someplace, and those may leak out as referrer headers. Okay. Now there were things to do to mitigate against this. Like the parameters were actually passed in the hash fragment that was supposed to protect against that. The history was still a problem, but you could write JavaScript to clear the history. So the older style was sort of the best that we had, and there were things you could do to clean it up and make it a little tighter. But anyway, the spec committee said, no, we really want the spec to just have built in a nice clean approach to making sure that you don't have to know to do all these extra things. So that's why we now get this code. Okay? Now the code is received back in your SPA. And the SPA will now make programmatic calls to the token server to that token endpoint that I mentioned. And this is where we exchange the code for the tokens, okay, which is the access token is what we're going to use to call our API. So you might look at this and say, well, if we change the protocol flow to use code flow because we didn't like the stuff in the URL was maybe, you could somehow capture that. Well, what would prevent us from capturing the code as well and just making the same call to this token endpoint to get the tokens, okay? Now, if you've ever done OAuth or OpenID Connect in the past, you've probably seen sometimes if you're building a server-side app, you'll get a client ID and a client secret. And it's that server-side secret that is protecting the code so that nobody can steal it and use it as an attack vector. Well, in a SPA, can we embed a secret somewhere in your JavaScript? Yeah, not really. Okay, so this is where the other spec that I mentioned, proof key for code exchange, or PKCE, comes in. What it does is it allows us to protect the code here with sort of a dynamic or a temporary secret. And so the way that works is, I'm going to go back a couple slides. Notice then when we made a request to the authorized endpoint. This is basically using code flow with PKCE by that extra parameter called code challenge. What the SPA is going to do before it makes a request out to the authorized endpoint is it dynamically creates a secret. And we're only ever going to use the secret for this one exchange with the token server. So we don't try to store it anywhere. We just create it and hold it in memory. So you have a secret. The protocol then has you hash that secret. And that's this code challenge parameter. So what we're doing is we're sending a hash of a dynamically generated secret. Okay? Then, once we get back the code, the token server, when it generates the code, it's also storing the hashed version of the secret. Okay? Great. So now your JavaScript gets back this code. It makes an AJAX call back to the token server, back to the token endpoint. It passes its client ID, the code, and then the original dynamically generated secret. Okay? That's, by the way, called the code verifier. So on the token server, we had the hashed version. So what it says is, hey, I see your code. Great. I can look up my data in the database. I have your hashed secret. Oh, but you're passing me the plain text as the code verifier. So the token server will hash the incoming code verifier, compare the hashes, and now know that the app making the back channel call or to the token endpoint call with this code is the same app that made the front channel call. So it's guaranteeing or ensuring that if somebody has intercepted this code in transit, that they're running on some other server, they won't be able to actually exchange the code for the tokens. Okay? That's what PKCE is all about. And it turns out that in the spec committee, all of the flows that we've ever used in the past, this is now the recommended flow really for all of them. So if you have a server-side web application, switch over and you can use code flow with PKCE instead of like hybrid flow. If you're running a mobile app, right? You can run a mobile app, do the same protocol flow, code flow with PKCE, okay? So really, the nice thing about this is that, if you've ever learned about this stuff in the last 2 to 3 years, you have all these flows you have to remember, and hybrid flow, and this flow, and that flow. It's really simple now. For an interactive app with a human in front of it, code flow with PKCE, right? That's it, just one to learn, okay? Oh, and by the way, the ASP.NET Core team in 3.0 is adding code flow with PKCE to their OpenID Connect middleware, okay, for your MVC style apps. Okay, good. So the results from that token endpoint, are the identity token and the access token. I mentioned that these tokens, the identity token is something called a JOT. This is basically a JSON data structure that is encoded, has a digital signature on it, contains some protocol claims, but the other main thing it contains are the claims, the information about your user that you had asked for with those scopes. So we asked for the scope OpenID. That means I want the subject claim, which is the user's unique ID. I also asked for the email scope, which means I want some email claims. I also asked, I think, for profile, which is like your name, your first name, your last name, things like that. Maybe we didn't get those back, but the idea is that those are the claims you're getting back. And these are meant, this ID token and the claims inside are meant for the front end portion of the app. The ID token is only used by the SPA itself, okay? Then we have this access token, and that's what's used to actually make our AJAX call back to the server. And of course, on the server side, you have to validate that. So here's some JavaScript that shows you how old I am, right? Basically, I'm doing some old school XML HTTP request. I'm going to set the request header, which is the authorization header, and you use the bearer scheme, and that's where you pass along the access token. And this is how now the token gets sent on every call to the token server, and then you process the results, normally. Okay. And then on the server, the web API that you're actually invoking needs to validate that incoming access token. And if you're using ASP.NET Core or Owen and Katana, there's helpers in those frameworks for that. So I understand people use other tech stacks as well, but whatever tech stack you're using, there's going to be some equivalent piece of middleware or infrastructure server side that will validate these tokens. Okay? Okay, so I do have some sample code, so let's switch over and do that. I just wanted to kind of get everybody on the same page in terms of the protocol flows. What I have here is now a very, very simple SPA application. Okay, and again, you can obviously tell my design skills are on par with my security skills here. So here I have a very simple SPA or JavaScript application. I'm going to go log the user in. I'm going to then get some tokens back. I'm going to say, oh, you're Brock, welcome back. Have my API. Access token to call my API. And then we'll talk a couple other application things like renewing tokens, there's a concern there, and of course, logging the user out, okay? So the way this works is that I'm actually using a helper library called OIDC Client. This is a JavaScript library that I actually built and had certified by the OpenID Foundation to be spec compliant. At the time I was building this stuff, there were no JavaScript libraries out there to do these protocols, so I had to build one. Okay? And so the idea is I'm pulling this in here, right, this library. I have my event handlers for my buttons, and then what I'm going to do is set up some configuration. And this is configuring, building the configuration for my JavaScript client application. So there are some settings here like what's the token server that I'm trusting. So I just have a test token server up in the cloud. This is actually a copy, an instance of identity server. We have to configure things like the client ID, the response type, and the scope. Those should look familiar from the prior slide because these are the parameters that we send on the protocol. This library does, in fact, support CodeFlow with Pixie. Okay, so there's actually a customer here in Europe that sponsored that feature at the end of last year. So thanks for that. And so here we are now with support for your SPA for the proper, the recommended protocol. This only supports CodeFlow with Pixie, right? So you can pop that in here, and it's going to automatically do the Pixie piece. Okay? So you configure this stuff. We come down here, and then when we create an instance of this user manager class, the user manager is going to do two major things for us. One is all the protocol work. So it knows how to build the URL to the authorized endpoint and make calls back to the token endpoint, as I described earlier. It also does your session management within the SPA, which means when we get the results back, we have to kind of keep track that there is a user sitting here. And so really what that means is that there's some storage in the browser that these results are kept in. And that's where your tokens reside, okay? So when we load up the application here, what we're going to do is invoke this first helper here called getUser. This will let you know, this will attempt to read the storage and see if there is, in fact, already a session. So if there is a session, you'll get back a user object, which is really just a deserialized object from the storage, the JSON that's in storage. Great, so we'll have a user, and this user object has your tokens, your ID token, your access token, the access token being the thing that you care about to call your API. And it will also have any of the claims that came back in the ID token. So this library deals with parsing the ID token and doing all of the work necessary to get the user's information for you. So there's a profile property where all those things hang off of, okay? So if you have a session, you're good to go. If not, well, then I just print out the fact that I don't have a user right now, and which is exactly why that's being printed, okay? All right, so of course, when I click my login button, I'm gonna go trigger the redirect to go log in, right? This is like sending your user to your login page, except it just happens to be in a different domain. It's the token server that you've established trust with. So we're gonna send the user away, and when they come back, as you notice, my redirect URI, I'm sending them back to my callback.html page. So in here, I'm basically reinstantiating the user manager and calling the corresponding paired method, if you will. So I do sign in redirect to get the user out, and then I'm using sign in redirect callback to process the results when they come back in, okay? Inside of this call, it grabs the code from the URL, it makes the call back to the token server, exchanging it for the tokens, and doing the rest of the protocol work necessary to know that that's all valid, okay? It then takes the results, stores it in storage, right, which is your tokens and the information about your user, and then we'll raise the success event here, and you'll be able to then do whatever you need to do next, which in this case, I'm just gonna take the user back to my little home page, okay? So then back on my home page, when I reload, right, because that storage will have survived the page redirect, yeah, I'll just load up, and now I should see that we have a user session, okay? So let's give that a try. I will call login. And actually, you know, I'll even do that one more time in the debugger here, or not the debugger per se, but the network trace, right? So what I'll do here, call login, okay? So a couple things that happen first is for my JavaScript app to first know what the URL is for the authorization endpoint, it first actually queries that discovery endpoint that I mentioned, and it's getting back all that JSON. And with the JSON, now it knows the actual URL for the authorized endpoint, and as you can tell, it has built up the parameters for that request, including our client ID, our redirect URI. Here is the fact that we're using code flow. Here are the scopes I configured. And if you look here, here's the code challenge that I talked about. So that's that pixie, that dynamic secret that's being generated, hashed, and sent along. Great. So now let's come in here and actually log in. Alice and Alice, of course. Okay. We come back to my application. And where did we pick up here? So we came back to my application. We ended up going back to my callback page from the token server. The token server had sent back the code, right? A few other parameters coming back. My callback page loads up my library, requeries the discovery document, so it now knows the token endpoint. And if you see the call is being made to the token endpoint, and if we scroll down far enough, you'll see that the authorization code is being passed, along with the code verifier, which is the plain text version of that dynamic secret. Okay? And what came back from that was a few other things, like our tokens. And after all of that, then the session was established by putting a record in session storage. So the library chooses session storage by default because that's just per window. So if you close the browser or close the window, that data is gone. You can swap this out and use something else like local storage or even IndexedDB, but I think I actually prefer the session storage approach. And so what's in here, as you can tell, is just a JSON object that's been serialized, and it has the access token and the ID token. And this profile then is where all the claims came back that I had mentioned that are from the ID token, okay? So now this access token, if I look at this guy, and run a website called jot.ms, pop the access token in here, you can see that now this access token is intended to be used at my API, okay? And this has things like, hey, here's your user's unique ID, subject ID 1, that's Alice's 1, okay? So anyway, that's the access token that I would then send to my API. So this storage here for my user, right, has all these things in it. And when I call my get user, well, as you can tell, that user object I got back is just the deserialized object. And then I'm just re-rendering it on the page so we can see what's inside. So yeah, when you make that callback to get the user, you have the .access token, and you have .profile, .name, .email, whatever you need. Okay? All right, so how do we then invoke the API? Well, of course, I have my little call API method here. I'm going to reload my user. I'm doing my old school AJAX call. I'm setting my request, my authorization header based on the access token. And if that all works, I should be able to see that, yeah, I was able to pass that access token. And just to show you on the network here, right, I was able to pass that bearer token along, and here it is in the outgoing header. Okay? The API then was able to validate it, and all the API is doing is then just echoing back the contents of the access token just so we can see that it worked. Okay. Great. Cool. Any questions about that? Yeah, talk loud.
Do you know why the dynamic secret is passed as plain text to the token endpoint and as a hash?
So why is the secret passed as plain text on the token request? Because you have to prove that you have the secret.
You could pass the same hash again like you did the first time?
Yeah, then what was the point of hashing it in the first place? The hash becomes the secret itself. So, yeah, I see what you're saying. They actually have a provision in the spec. If your client-side app can't do hashing, you can just do plain text. But yeah, I mean, that's how the spec was written, right?
Related to that, does that mean that the client secret idea, or the concept of client secret is going to go away as a concept?
So the question is just related probably to my comment about all the other protocol flows are now using code flow with Pixie, or that's an encouraged flow. Yeah, I mean, in a sense, in theory, the client ID could go away. I'm sorry, the client secret could go away, which is what you asked for. There might be other interactions, though, that your app does need to make to the token server for other things where that client secret still is needed, okay? So refresh tokens would be one of the prime examples of that, okay? Now, one thing I actually want to show you here is that notice I did not obtain a refresh token in this workflow. So for those of you who know about refresh tokens, it's a way to renew access and get new tokens. So that's actually the next thing I'm going to talk about, which is this renew token. So for server-side apps, sure, you can still use refresh tokens the way we've been using them for a long time. But in that guidance that was put out by the IETF to now that you can move to code flow with Pixie, they actually have a section here that explicitly indicates refresh tokens in a SPA, since you don't have a secret, are very powerful things. And if that refresh token is ever exfiltrated from your app, now an attacker can just keep getting new access tokens without, on behalf of the user, without anybody, necessarily knowing. Now, there are other mitigations you can take, other hardening you can do in your token server. You can do one-time refresh tokens. You can invalidate the entire session if that fails. But I've not seen any token server, even identity server itself, doesn't have all the protection measures specifically for refresh tokens without secrets for SPAs. So there are things that spec suggests, but they're still working on it, and they really need to flesh out the guidance there. So at this point in time, it's not really recommended to use refresh tokens from these SPAs. Okay. Now, the thing that we kind of want in the future is something called a sender constrained token. And a sender constrained token is a token that basically is tied to the caller. So there was a feature a while ago that the HTML or HTTP spec group is working on called HTTP token binding. And it was basically a specification that allowed you to issue a token. And they, I think, intended it for cookies, but we could also do it for these type of tokens, where the cookie, when the website issued it, the cookie would actually be cryptographically bound to the TLS session. So if somebody ever stole the cookie and tried to submit it from another TLS connection, it would be, you would detect this and reject it. So that same technique could be added to these tokens. Okay, that's the concept of a sender-constrained token. Somebody else can't still send that token. unfortunately, and so the OAuth working group went and tried to, start building new specs for tokens on top of this HTTP token binding. And then Google one day said, oh, we're actually going to remove that feature from our browser. We don't think it's terribly useful, okay? And because Google has, such dominance with their users using the browser, it kind of killed the whole possibility of us relying upon that as a technique. So there has now been work in the OAuth working group on a new way to do sender-constrained tokens for JavaScript apps, something called Depop. It's demonstration of a proof of possession token. And it's basically relying upon the same concept, web crypto, and basically trying to have some sort of private, public-private key pair in that instance of the browser. And when you're doing your connection to the token server, the tokens you get back are now tied to that. So if the token is ever exfiltrated, it'll be detected and prevented. So until we have that sort of sorted out, okay, the recommendation is stay away from refresh tokens in the SPA, okay? That was like the longest answer for a question, I think, so. Anyway, okay, so I have a few minutes more. I can talk about a couple more topics here. So the next one is obviously, access token that you got back is usually only good for about 1 hour. And so the app can use the access token over and over and over at that API or however many APIs it's good for that hour, but at some point it's going to expire. And, like a cookie in a normal web app, you can issue your own new cookie. You can slide your own cookie because your app is the one consuming it and the app is the one creating it. We can't do that here because our app didn't create the token, the access token, it was the token server. So what we need to do is kind of like go back to the token server, right? See, look at the bottom, I have my expiration here. I'm going back to the token server, and I'm going back to the authorized endpoint, the same one I used at the very beginning to log in. It's immediately coming back because I have a single sign-on session, right? I have a cookie at the token server that represents my session over there. So this is actually working just fine. You can probably tell I'm getting new tokens as well, if you can see that. Yeah, I'm still getting new tokens, not a problem. The only problem is the usability is pretty bad, okay? So it turns out what the spec has you do is that same login request, right, that you're happening in the main window, you can use that sort of time-honored, like rock-solid HTML technology that we've been using for years and years and years to make requests to other websites so the user can't see it. And that is iframes, exactly, okay? So basically, we can use an iframe or make the same request in an iframe to obtain new tokens. And that's exactly what my little renew method here is going to do, is if I scroll down, I've wired it up to my method called silent, of course, because it's a silent renew. And the user manager in the library that I'm showing you has a sign-in silent method. So what this does is it creates the exact same authorized request. It actually has one more additional parameter called prompt equals none, and it's letting the token server know that this is really in an invisible request. It's in a hidden iframe. So if it needs to show an error page, don't, and just immediately return back to the app. So then this will make the request to the token server in the iframe. I don't know if you noticed up here at the top, but we had a silent redirect URI, which was where the silent response will be processed. And the main difference between this one is the response comes into the iframe, and the iframe isn't the one that wants to deal with the tokens. It wants to send that up to the parent window. So the parent window will then actually complete the processing and now have updated tokens, okay? This is another reason why, by the way, every time I'm calling my API, I am reloading my user from storage because the silent renew is just updating storage, right? And you don't want a cached version of the old access token. You want to, every time you're going to call the API, load the latest version, okay? So that's why the call API is doing this. Okay, so if I hit F12 here, go to my elements window and do renew token, I don't know if you guys can see at the bottom, there's an iframe being created every time I click the button here, and it's being successful. Obviously, it says here, silent renew success. So if I keep hitting this, you should see the expiration at the bottom is getting updated, and the values in that token are being updated. And then that can be used to call the API. And that's the approach in your JavaScript app where you keep getting new tokens. Okay? All right, a couple other things. I have, actually I have a few minutes left here. So you might ask, okay, well, when do I renew this token? Well, there are two approaches. One is you could keep using the access token at the API, and you'll get a 200 OK, 200 OK, 200 OK, and then all of a sudden you'll get a 401. Okay? 401, when you're invoking an API, means go get a new token. So that's pretty easy. You could just hook everywhere you get response back from your API, check for 401, do the silent, right? Get the result, and then reissue your API call based on the new token. Okay? The other thing you could do, though, is if you notice at the bottom, so if I hit refresh here, where is it? There it is, at the top there. We actually keep track of when the token will be expiring. That's just the Unix time of when it's going to expire. So you could imagine another approach to renew tokens, which is you set up a timer, right? And you set up a timer to proactively renew prior to the expiration, okay? So the idea here is that you can do this. Now, I wouldn't expect you guys to write that code. It turns out the library implements that for you, which is nice and easy. And there is an add access token expiring event that you can wire up to. So basically, this guy internally is already doing all of the calculations to keep track of that. So all you would need to do is handle this event, and then you could actually do the silent call, inside of here yourself, okay? There is even a flag on the settings that will do all of that automatically for you. But when I first added that setting, originally I thought that was a great idea. But the only problem is if you have the library keep automatically renewing tokens, when the user walks away from the computer for 2 or 3 hours, it's going to still keep getting tokens and tokens and tokens. So in retrospect, I kind of wish I had never added that feature. So that's why my recommendation is now do it yourself, right? Take this silent call, put it in here yourself, but put your own type of user activity monitoring on top of that. So if you detect that the user is no longer active, you won't automatically get tokens, okay? But you figure out the right balance for that for your app. Okay. So the last thing we have here is then the ability to sign out, and that's a pretty standard protocol feature. So we have a helper in here, wherever it went, to sign the user out. And when we sign them out, we have the ability to go send them to log out of the token server, and then we can come back and go back to the app and start over again, okay? Now actually check this out. If I try to renew my token, right, remember that makes the same login request. If I did it in the main window, would be prompted with a login screen. But if you try to do the renewal in the iframe, because the prompt equals none parameter is passed, notice it immediately comes back with an error, and that's because when we made the request, we sent prompt equals none, and then it immediately came back with an error back to that page because the token server respects the fact, oh, you're in an iframe, there's nothing to show, I just send back an error, okay? Cool. I have a little bit more time, so I'll show you one last little feature, which is I'm gonna go log in. And this last little feature is, great, you're now logged in. Right? As I mentioned before, we have a single sign-on session at the token server. So you could go and launch 2 and 3 or 4 more apps. If they're all trusting the same token server, all of them will just get signed in automatically. There's no more prompt for a password. Great. So let's say you have your spa up in one tab, and you have another app up in the other tab, and another app in another tab, and one of them you click log out. So now you're going to log out of that app. You're going to go to the token server in that tab and log out. But what about those other 2 or 3 apps that are in the other tabs sitting around? Wouldn't it be nice if they got notified that the user has signed out in some sort of other tab, other window? So it turns out that the protocol supports that as well. So I'm actually going to open up another window to demo that. So here I am. If we can see this, I'm logged in the other tab. Okay? And here over in the spa. And I'll show you the demo first, then I'll talk about how it's implemented. So the idea is that now over on the right, I'm in the other tab. I'm going to go log out of the token server. Okay. Oh, I need to do my demo better. Sorry. I have an event in the library, which is called add user signed out. Okay, which is basically an event that gets raised when this happens. Okay, so sorry, let me run that one more time. Okay, log in, Alice and Alice here. So back over here, I'm now logged in. I'll go log out. Okay. And again, I don't trust my cache, so I'm going to hit Control F5 one more time. Okay, good. Okay, so now over here on the right, I will log out. And there we go. Okay, took a little bit of a while, but not so bad. But the other tab said, oh, yeah, you're signed out. And then your JavaScript can say to the user, hey, I've noticed you signed out. You're done. Click here to start over. Cool. So that's kind of a nifty thing. This library supports that, which is basically a real simple event, and it's paying attention to what's happening at the token server. Okay? Now, this is the interesting question is, how is my SPA paying attention to what's happening at the token server? Okay? So the thing that we care about at the token server is when the cookie is gone. If the cookie's disappeared, that means you've signed out. Okay? So can the application running on localhost 5000 read the cookie from demo.identityserver.io? Yeah, absolutely not, right? Cookies can't be read cross-domain. So how does this work? Well, it turns out that the piece of code that can read the cookie from the token server is a page from the token server itself. So one of the features of the token server is this something called the check session, yes, iframe, right? Yet another iframe. And in this page, what's expected is your SPA is expected to open up an iframe to this check session iframe endpoint. And I don't know if I just lost my internet connection. Come on. Is it February 29th? Is Azure restarting? Okay, I think this worked. Yeah, okay, good. So what's happening here is now the application is opening up an iframe to this thing from identity server itself. So if you scroll all the way down, there's a bunch of JavaScript in here. But the thing that's interesting is in the app on the right, or the iframe, it's listening for the message event. Okay? What's happening is the SPA has an identifier for the current user session. And it's setting up a timer, and every 2 seconds making a cross-window call into this. Okay? And it's doing polling. The thing is, though, the polling is not network polling. The polling is just crawling from one window to the next. Okay? Once we're in the iframe, all of this has to do is take the SPA's session ID and see if it matches the cookie that's in memory in the browser that was issued from the token server. And if they're the same, then the page here responds back with a message called unchanged. So we send a message back saying, nope, nothing's changed. Okay? So every 2 seconds, is it the same session? No, nothing's changed. Is it the same session? Nothing's changed. Then the user logs out of the other tab, the session cookie is gone, and now the next time the JavaScript or the SPA calls into the iframe says, oh, your session ID doesn't match anymore. Something, in fact, has changed. And then that's how the SPA can detect, oh, your session is no longer valid at the token server. Okay? Sounds like quite the hack, doesn't it? Well, that's exactly what the spec told us to do, so we did it. Okay? All right. So anyway, that's the last kind of nifty little feature here with this library is that you can track the user's session at the token server and be notified for single sign-out scenarios. Okay? Okay, so there's the library. There's the GitHub repo with it if you're interested in checking out the code. We already talked about the expiration, the fact that we're going to do this silent renew with an iframe, and we're not going to be using refresh tokens. And we talked about the couple of things related to signing out and participating in the single sign-out notification. Okay? So other than that, I am done. So again, the summary here is if you're building same-site JavaScript SPA apps using an API, totally use cookies. Same-site cookies are really going to be the way to go. But if you need a more complex architecture, then you're going to need to move to tokens. You can have cross-domain calls, other apps using that API. You need a token server as well, of course. And yes, it is more complicated, but that's the price you need to pay for that sort of flexibility in that architecture. Okay? So thank you so much, and enjoy the boat cruise tonight. Thank you.